Hello, everybody. My name is Jakub, and I work at HAProxy Technologies. You might know of us as the company behind HAProxy, the legendary open-source software load balancer that a lot of you are probably using. Today, I'm going to be piggybacking on the previous keynote about performance and security and LLMs, because I think there are a lot of topics we should talk about. I talk to a lot of our customers, and they all say, we're all in on AI. But I think the risks of that are yet to be understood. I think we're kind of in the 2003 of OWASP top 10 for web security right now in terms of LLM security. So when they talk about, I'm being all in on AI security or an AI, the first step that you usually think about is, well, we're going to build an AI gateway. And so what's an AI gateway? Well, it's an API gateway, right? We've all built one at this point, or most of the projects in load balancers have built one API gateway right now, an AI gateway. So we're going to do some authentication, we're going to do rate limiting, we're going to do PII detection, or maybe PII extraction and prompt routing before we send the data to an inference engine, which is ultimately an HTTP API. But I think one of the things that's missing there, or possibly missing, is prompt security. And that's really, the ignore all previous instructions that doesn't work anymore, or a time bandit attack that used to work with OpenAI until recently. So there are obviously solutions to that. For example, there's a prompt guard model and a llama guard model from Meta. There's a shield gemma from Google. And in the end, many of these are built on some kind of a variation of DiBerta classification. It's a set of models, so they are actually large language models that are classifying. You ask, is this prompt safe, yes or no? And they answer yes or no. So it's ultimately a classification problem. So we're going to add prompt security to the AI gateway and basically run the model itself in the AI gateway. So I did that, and I ran these models inside an AI gateway, inside a load balancer. And ultimately what I found, and this is what I want to talk about, is it's pretty slow. So if you run a model like this on a G6X large AWS instance, which is ultimately a pretty big instance at this point, if you start approaching 500 tokens, it takes somewhere between 150 to 200 milliseconds to process the prompt. And most prompts are bigger, and most of these models have a context window of about 500 tokens. So if your prompt is 2,000 tokens, you have to do this 4 times. And that's a second of time you're processing. That's lifetimes in a load balancer world. And if you start doing this in parallel, like a proper AI gateway, it gets worse. So here's, if you can see, I ran an optimized model, so basic transformers, and then an optimized model with an inference engine. And on this instance, you cannot almost ever reach more than 60 requests a second. And once you start getting to a concurrency of, let's say, 8 concurrent requests, you will never reach over 40, basically. So there's a lot of work to be done in making this faster. There are optimization strategies. We can run an optimized inference engines. I did that, and you can get about 30%. You can enable token caching, but ultimately token caching, as we know it right now, is meant for generative AI. And we're not doing generative AI. We're doing classification. We're classifying the models. So it's out there to know if this is useful long term. There are some advanced techniques. I've tried these as well, and it works. Like, you can filter for some of the basic prompts and bad words with text filtering. The only problem is, if you make a typo in the filter or in your text, the text filter will no longer work, while the LLM will interpret it correctly. So all you have to do is mangle a few words, and it's just going to work. So I think there are a few lessons learned. We need to innovate new techniques using the tools we have, and we have a few tools. 2, using the AI itself to secure AI in the load balancer works, but it's still out there if it's viable. It's something that we are researching. We might need to research all together some smaller models that can run on a load balancer and can run much quicker. And 3, I think that the AI gateways are necessary, but the security is evolving. In the end, as I said, I think we're in the 2003 of OWASP top 10 right now in AI security. Everybody's trying something, everybody's doing it, but we don't know what's going to work a few years from now because it's really hard to keep up. So thank you so much. If you have any questions, please come to the booth. I would be happy to talk about this a little bit more.
Thank you, Jakub.